Okay, so I get occasional questions about slip yoke eliminators, and also kind of connected to that, I get the question, do I carry a spare drive shaft as part of, my off-roading supplies when I go out? And the answer is no, I don't carry a spare drive shaft for the rear. So this part of the drive shaft actually rides on the seal and keeps the fluid in the transfer case. That's where this comes in. See, it's hollow. And this is why. Let's actually take two. Originally, when I first filmed this, I had grabbed my old set that I've had for years, and I noticed that I haven't used it for a while. It was very old and brittle, this old red set. So the old one that I had for like over 10 years was getting a little worse for wear, so I decided to order a new one from Amazon. So basically, you know, slip yoke eliminators normally are here because this is a slip yoke on the rear drive shaft. And if you ever have to take the rear drive shaft out, you see that right there. So this part of the drive shaft, this smooth, shiny part, that's where the seal rides, and it seals up in there. And if you take this drive shaft out, let's say you have some kind of a drive shaft failure or something, and you have to, try to limp home in front-wheel drive, you can't do that because you're going to lose fluid as you drive. You're going to lose all your transfer case fluid quickly right out that hole. Now, you can see kind of some green. That's actually clean grease that I installed on that to help the seal when I was doing new U-joints on this drive shaft. But my new set showed up, so let's test it and make sure everything fits. So, this set, by the way, $13 on Amazon. I'm thinking it's going to be one of these. You can see they're double-ended, so you've got these two actually do 4 sizes. So you just need to figure out which. Oh, that's too small. Still too small. Hey, that's the size. The smaller of these two sizes. So pretend like you had some sort of trail failure of your rear drive shaft. You take it off. You can't drive home because that's going to lose all your fluid. There you go. That slides in nice and tight. And that is much larger than the splines of the shaft. So basically that's not even touching the shaft. So it'll keep the oil in the transfer case, seal it up, and let you drive home in front-wheel drive without having to carry a spare rear drive shaft. This right here is why I don't carry a spare rear drive shaft. Actually years ago I had a rear drive shaft failure on a different vehicle, and it was my daily driver, and at the time, I was like 21 years old, didn't have the money to replace the yoke and the new drive shaft and everything, so I drove around as my daily driver in front-wheel drive for weeks with this stuffed in the seal, and this actually made it through, and it actually was just fine. It was kind of weird driving around front-wheel drive with lunchbox locker in the front-wheel drive. That made it kind of awkward to drive, but things you do when you're 21, right? Okay, so slip yoke eliminators in general are, they're a good thing if they're available and easy to install. But what we usually see them for, and the desirability is usually on vehicles like Jeep. Jeeps, for example, look at the rear drive shaft on a stock Jeep. I've installed dozens of slip yoke eliminators on Jeeps that have what starts out as like an 11 or 12 inch rear drive shaft. And so, yeah, they need a slip yoke eliminator, because what that does is as you eliminate that shaft and add your attachment point for your yoke clear over here, you actually take what was originally an 11 or 12 inch drive shaft and turn it into a 22, 23 inch drive shaft. So what that does is on Jeeps who really need it,
it lessens the severity of the driveline angles. It also allows you to run a double cardan style shaft. So Jeeps need slip yoke eliminators, big time. But the extreme difference in angle and in the very short distance it has to make that change. Also, slip yokes, when it's got to slide this way, when the drive shaft is changing length this way, it puts a bind on it and often causes failure, cracking and breaking of the actual transfer case housing because it's pulling downward instead of sliding out. And so there are, especially in those extreme cases like in a Jeep, a slip yoke eliminator is just a really good idea. So yeah, slip yoke eliminators if possible, not a bad thing. But for what we're doing, first of all, the drive shaft in our GMT 800 trucks are like 5 feet long. So that's being spread way out like this. And so, yeah, the pull on the shaft and splines is a lot more linear. It's not trying to pull down as much. It's still actually pulling out. And also, the driveline angles are very minor compared to the extreme angles created on a Jeep. So there are no slip yoke eliminators available for our electric shift transfer cases in the GMT trucks. They're just not really available. And it's not worth going out and trying to find one. It's really not. And so one of the other benefits that people see as having a slip yoke eliminator is being able to, if there's a drive shaft failure, you can just unbolt the drive shaft and keep driving. And what's actually sparking this video is I had yet another person ask me, this question gets asked pretty regularly, do you run a slip yoke eliminator? Well, no. Well, then what do you do if your drive shaft fails? And so that's what kind of sparked this video, because I was getting ready to leave for Moab anyway. But basically, a $13 kit from Amazon, and I'm good. I don't need to take up the space of a 5 foot long drive shaft in the back of my Tahoe, and I can usually get off the trail and get to somewhere near civilization enough to make the repairs needed to get home, or I can also just drive it home in front wheel drive. That can be done as well. So it doesn't justify to me the difficulty in the space it takes up inside the vehicle or tied to the rack or something of carrying a drive shaft. First of all, the infrequency of failures of the drive shaft on these, and even if I had one, how easily I can just get off the trail and get home without having a spare drive shaft. So personally, I choose not to. And not only that, is that if you ever had a drive shaft failure, most of the time you have a failure where you have a yoke fail. Usually the yoke on the differential also gets all torn up when a drive shaft fails. If it's a rear joint that fails, which it often is, it also tears up the yoke at the differential end, this part. So that now you're taking this off, hoping you've got a spare yoke, which you probably are going to carry a spare yoke too, but then you've got to get that changed out. And so it's like, do all that, or just put a plug in and get somewhere a lot easier to fix it. Now also, these GMT 800s, they don't have a lot of drive shaft failures because basically they have a link suspension in the rear, and a properly engineered link suspension maintains correct U-joint angle as the drive shaft and differential move up and down, and that means that the U-joints don't bind, and so you don't have a failure. Now most of the time you have a failure, it's because your U-joints are binding. They get out of alignment and they bind and blow up, okay? Leaf springs are totally prone to binding and failing when it comes to U-joints. And that's because two things. First things first, leaf springs, the yoke stays relatively, in place this way as the axle goes up and down, okay? But also leaf springs don't have anything to prevent what we call axle wrapping, which is the pinion gear trying to climb the ring gear under load, and so it twists the differential and the pinion upward on a rear drive shaft. Does that make sense? And so then that also causes U-joint binding. And then when that U-joint binds, boom, everything blows up. And that's when you have yokes fail, U-joints fail, drive shafts broken. And that axle wrapping under load is exactly why you see a lot of these trucks, especially usually diesel, street towing trucks, have these big, long traction bars. Some guys call them track bars. I think just shorten tracks to track bars. And that's to prevent the axle from wrapping while they're under load. And it's really funny is because those rear track bars need to have the exact same geometry of a radius arm, which is it needs to actually make the needs to have the pivot point be in the same relation to the U-joint at the transfer case, so that it keeps the correct U-joint working angle at the pinion, especially when you're under load. Like, that's when you need it, is when you're under load. Yet these guys, maybe it looks cooler and flashier to them, or they think it's better because longer is better, but sometimes you'll see these trucks have traction bars that go way further forward from the U-joint pivot point on the drive shaft, and that's basically meaning that those bars do prevent axle wrapping, but now they're actually forcing the axle to operate a pinion angle that is, as the suspension cycles, incorrect. And so what's the point of putting on something that will maintain incorrect pinion angle? But again, people just don't understand geometry of arms. I see it a lot. So basically, yeah, what you need to do if you're ever going to do a leaf spring setup with a rear traction bar setup, the pivot point of the traction bar needs to be front to back in line with the U-joint and as close to the pivot point up and down as far as height-wise, so that as the suspension cycles, it keeps maintaining the correct U-joint working angle, and therefore making your U-joint be as strong as possible when it's under load. And so link suspension they make your drive shafts last so much longer, especially in situations off-road where you've got the tires bound up and you're spinning tires and trying to climb and hop and get up over things. It's a huge difference, and that's another reason why you shouldn't swap leaf springs into the front of your vehicle if you're doing a solid axle conversion, because front differentials, same thing. They can wrap, but they don't wrap up. They usually wrap down because of the rotation of the drive shaft. So a rear pinion wraps up, a front pinion wraps down. Same thing though. It's changing the geometry of the U-joint, causing U-joint failures, and that is why proper radius arms set up in the front is crucial, so that it maintains the right U-joint angles as well, so that when you're really abusing this thing off-road, you're not going to have U-joint failures. Now, there is one sort of caveat to that, and that is that when you have link suspension that maintains pretty neutral, U-joint working angle at the pinion, your U-joints do last way longer because they just aren't cycling as much. But when they do fail, it's because they kind of wear in one spot on one side of the U-joint because they just don't ever cycle. Show how stuck that U-joint is. And so they get kind of sticky in one spot. And that's fine because that's how they're going to fail. That's a wonderful way to have a drive shaft fail, I promise, rather than blowing up or U-joints obliterating. And they do it way longer down the road than you usually have, like a leaf sprung U-joint last. So just something, there is a caveat that when they do fail, they fail in like one specific way, but who cares? It lasts way longer than ever would with leaf springs. So just something to think about. Now, it's up to you if you want to carry a spare drive shaft. I mean, great. It's up to you if you want to justify the expense of trying to do some kind of a slip yoke eliminator. But for what these vehicles need, it would be just wasted money. Because what's really awesome is that using these electric shift transfer cases, if I did have a drive shaft failure, I could get just a drive shaft from anywhere as far as a used one or a stock replacement one. Nothing really custom is needed for the rear drive shaft of my vehicle. And that's really convenient. So I could be, down hundreds or thousands of miles away from my home and be able to find replacement parts pretty easily. And that's definitely something worth considering when you're going to be doing long distance traveling. So, thanks for watching.